Hi everyone and welcome back to another lab. This lab is very similar to the one where we discussed how to configure IPv4 default and static routes, and because of this I won't be going over the lab topology, the lab objectives and the tasks again. Instead of this, I will include a link in the video description below for those who missed that lab. By the end of this video, you will be able to configure default and static routes on Cisco routers and establish connectivity between different end hosts across various networks using IPv6 protocol. Okay, so with that being said, this is the moment where I ask you to pause the video and try this yourself to test your knowledge and skills. So I have added the lab document in the video description so you can download it and practice at your own pace. I have also included a couple of packet tracer labs for you to download. You will find a pre-lab and a post-lab versions. The pre-lab is for those who want to tackle all tasks from the beginning, and the post-lab provides the full lab solution. Okay, so what I'm going to do, I'm going to tackle the first task, and the first task is all about access ports configuration on both switches, the headquarter switch 1 and branch 1 switch 1. So I'm going to start with the headquarter switch 1 switch, so I'm going to click on it and then I'll go to the CLI. And then from there, I'll go to user privilege mode by issuing the enable command. And from there, I'll go to the global configuration mode. And then the first thing that I'm going to do, I'm going to create the VLAN 100. So I'm going to say VLAN 100. Let's name that quickly. So I'm going to say VLAN 100. I'm going to exit this, and then I'm going to configure the interface gig Ethernet 0/2, which is connected to the headquarter router 1. So I would say interface gig Ethernet 0/2. I'll set the description quickly, where I say link to HQ underscore R1, and then I'll set the switch port mode to access. I will then assign the VLAN, so by saying switch port access VLAN 100, and that is done. Let's jump into the interface that connects to PC3 and PC4. So the interface that connects to PC3 is actually Fast Ethernet 01. So let's tackle that first. So I'm going to say interface Fast Ethernet 0/1. Let's set the description. So I'm going to say link to PC3, and then do the same thing regarding the switch port mode access, and then switch port access VLAN 100. And that is done. Let's jump into Fast Ethernet 02 and then change the interface description to link to PC4. Let's set the switch port mode to access and then set the VLAN ID under that interface to 100, because by default is actually VLAN 1. And then once we've done that, then we can just end this and we can actually issue some commands to verify our configurations. So I'm going to actually issue the show VLAN brief, and you can see we've created a VLAN 100. The VLAN ID is 100 here. This is the VLAN description. Currently is active, and you can see there are 3 different interfaces that are members for VLAN 100. Let's execute the show interface status command, and you can see gig Ethernet 02. This is the link to the headquarter router 1. All interfaces, or these 2 interfaces, currently are connected, which is good, part of VLAN 100. And here that interface, you can see that is not connected at the moment, and the reason being is because the other side is actually admin down. Let's just quickly examine the configuration. So we're going to say show run pipe section, and then I'm going to say 0/1, and I'm going to put the $sign. And you can see that Fast Ethernet 01, this is the config under that interface. And if I up arrow that and I'll just hit the 2, you can see that interface gig Ethernet 02 as well as Fast Ethernet 02 configurations. So now that we have completed the first half of the first task, let's jump into the branch 1 switch 1 and do the same thing. So I'm going to go back to my topology and I will select the branch 1 switch 1, go to the CLI, and then the first thing that I'm going to do, I'm going to create a new VLAN, which is 101. I'm also going to name it VLAN 101. And then I'm going to configure the interface gig Ethernet 02, which is connected to branch 1 router 1. So I'm going to say interface gig Ethernet 0/2, and I'm going to say the description. And here I'm going to say link to branch 1 underscore router 1. And now let's just configure fast Ethernet 01 and fast Ethernet 02. So I'm going to say description, link to PC1. And then let's just configure quickly fast Ethernet 02. And now that we've completed this, let's just perform some in-flight checks quickly. So I'm going to say show VLAN brief. Again, we get similar output, but this time is VLAN 101, much like what we have just configured. So let's just execute the next command, which is interface status. And right now you can see that the first two interfaces are connected to PC1, PC2. Currently they are connected in terms of the interface status, and the current VLANs are 101, as you can see on the screen. And again, you can see the gig Ethernet 02 is connected to branch 1 router 1, and right now is not connected, and again because the other end is admin down, and right now is also part of 101 VLAN. Next, we can jump into the second task where we need to jump into branch 1 router 1 and perform some basic configuration. So let's do that quickly. So I'll just go back to my topology. I'll go to branch 1 router 1, go to the CLI, and from there I'll go to user privilege mode, and then global configuration mode, and then I will configure the first interface, which is gig Ethernet 0/0/2, which is connected to branch 1 switch 1. So let's configure that quickly. So I'm going to say interface gig Ethernet 0/0/2, and let's set the description. So I'm going to say description, link to branch 1 underscore switch 1. We would need to issue the IPv6 enable command, and this command enables IPv6 processing on that interface. So it allows the interface to communicate using IPv6 and perform basic IPv6 operations. So it is essential. So I'm going to say IPv6 enable. So at this point, we can then go ahead and assign IPv6 address to that interface. So we're going to say IPv6 address, and then we're going to say 2024:2000:10, and the subnet mask is going to be 64. And then we would need to enable the interface. So we're going to say no shutdown. And then let's jump into interface gig Ethernet 0/0/0, where we need to configure that link or that interface that is connected back to the headquarter router 1. So I'm going to say interface gig Ethernet 0/0/0. I'm going to set the description, link to HQ_R1. And then again, I'm going to have to enable the IPv6 services under that interface. So I'm going to say IPv6 enable. And then after that, I'm going to say IPv6 address 2024:2000, and then 1000::2. And the subnet mask is going to be 126. And then next we will need to enable the interface. So I'm going to say no shutdown. Now we can exit the interface configuration level, and we also required to execute the IPv6 unicast routing command, and this is very essential for any Cisco routers that needs to route IPv6 traffic between different networks. And without it, the router will only be able to process IPv6 packets locally, but not route them to other networks. So I'm going to say IPv6 unicast routing. And then let's just end this and let's perform some in-flight checks. So I'm going to say show IPv6 interface brief. And what you see on the screen, much like what you see on the show IP interface brief for IPv4 address, we have the interface ID here. We have the interface status. Right now you can see it's in the up down, and again the reason why is up down is because the other end of that link is actually shut down, and the first entry under this interface is the link local address. So every IPv6 enabled interface automatically gets a link local address starting with FE80, and this address is used for communication within the local network segment and is crucial for the NDP protocol or neighbor discovery protocol. The other IPv6 address, this is what we have assigned under the interface gig ethernet 0/0/0. We have assigned that manually. Similarly, with gig ethernet 0/0/2, you can see the current status is in the up state. Again, this is the link local address, and this is the IPv6 that we have assigned for that particular interface. Let's quickly execute the show running command to look at the running config under each interface that we have configured. So I'm going to say show running -config and then pipe section 0/0/0, and I'm going to include the $, and you can see this is the current configuration that we pushed under this interface. Let's do the same thing for the interface that connects back to branch 1 switch 1, and here is the configurations under that interface. Next, let's check if IPv6 unicast routing configuration have been taken. So I would say show running and then pipe include IPv6 unicast -routing. And you can see that we indeed have configured the router with this command. So with that being done, what we can do next, we can jump into PC1 and do or perform some local connectivity between PC1 and PC2 as well as the default gateway. So I'm going to go back to my topology quickly. I'll go to PC1 and then go to desktop and then command prompt. And then from here, I'll just issue the ipconfig command, and there you will be able to see the IPv4 and the IPv6 information as well. So right now you can see the current IPv6 information is the 2024:2000:1. And this is the default gateway, which we just configured under the branch 1 router 1 interface that is pointing to branch 1 switch 1. So if we issue the ping command and then followed by 2024:2000, and then there's going to be ::2, that will be the IPv6 address for PC2. We have successful ping, and if I up arrow that, and I'll just include the 10, which is the default gateway. And sure enough, we have connectivity and reachability between PC1 and PC2, as well as the default gateway for both of them. Okay, so now let's jump into headquarter router 1 to perform some basic configuration, since this is the next step or the next task. So I'm going to go back to my topology and I will click on the headquarter router 1. And then I'll go to the CLI. And then I will start configuring the interface gig ethernet 0/0/2, which is connected to headquarter switch 1. So I would say interface gig ethernet 0/0/2. Let's set the description. I'm going to say link to HQ_ switch 1. And again, we need to enable IPv6 services. So I'm going to say, or under the interface, so I'm going to say IPv6 enable. And then I'm going to say IPv6 address 2024:1000:10, and the subnet mask is going to be 64. I will also need to enable the interface, so I'm going to say no shot. Now let's jump into interface gig ethernet 0/0/0, which is the link that connects to branch 1 router 1. So I would say interface gig ethernet 0/0/0. Let's set the description. Let's say link to branch 1 _ router 1. Again, we need to issue the IPv6 enable command and then IPv6 address 2024 colon 2000 colon 1000 colon 1, and the subnet mask is going to be 126. Let's enable the interface. And then the last interface that we need to configure is the interface that is connected to the ISP router. So we would need to say interface gig ethernet 0/0/1. Let's set the description. So I'm going to say link to ISP. I'm going to say IPv6 enable. And then IPv6 address, and that's going to be 2024 colon 2023 colon 1, and the subnet mask is going to be 126. We mustn't forget that we need to enable the interface, so we're going to say no shot, and then I'm going to end this, and now we can perform some in-flight checks. So I'll say show IPv6 interfaces or interface brief. And sure enough, we have 3 different interfaces. Gig Ethernet 0/0/0 that is configured with this IPv6 address. As I mentioned earlier, this is the link local address. And right now is in the up state. So layer 1 and layer 2 are good to go. And the same applies for Gig Ethernet 0/0/1. Has this IPv6 address. And finally, the IPv6 address that is assigned for Gig Ethernet 0/0/2. And all of these 3 interfaces are in the up state. Now let's jump into examining the running config for the Gig Ethernet 0/0/0. So we would say show running -config and then pipe section 0/0. And then I'm going to hit enter. And you can see that we have displayed the running config for all these 3 different interfaces in one go. So the first section here is under the interface Gig Ethernet 0/0/0. You can see this is connected to branch 1, router 1. Doesn't have an IPv4 address that's assigned to it. And you can see the IPv6 address that is assigned to that particular interface. And IPv6 is being enabled as well. Similarly with the Gig Ethernet 0/0/1, which is connected to the ISP, and finally the interface Gig Ethernet 0/0/2 that is connected to the headquarter switch 1. Next, let's examine the IPv6 routing table. So I'm going to say show IPv6 route. So what you see on the screen here, for example, the first entry of the routing table, the C starts with C, which indicates that it's connected route, which means that the network is directly attached to the router, and that is via the Gig Ethernet 0/0/2. Whereas the second entry of the routing table starts with L. This is a local route, meaning it refers to an address assigned to one of the router's own interfaces. So that particular IPv6 have been assigned to Gig Ethernet 0/0/2. And the same applies for the third or the fourth entry and the fifth entry. Okay, so regarding the last entry of the routing table for IPv6, again, the L indicates that the route is a local route. Regarding this IPv6 address, which is FF00::/8, this is the destination prefix, which is, in this case, represents the range of IPv6 multicast addresses. It covers all IPv6 addresses that starts with the FF hexadecimal characters, meaning it encompasses all multicast addresses. And multicast addresses in IPv6 are used for sending packets to multiple destinations simultaneously. Regarding this output that I'm highlighting on the screen, which is the square bracket 0/0, the first number 0 is the administrative distance, which indicates how trustworthy this route is. So for local routes, the administrative distance is always 0, meaning they are the most trusted. And the second number, which is also 0, in that case is the metric associated with the route. For local routes, the metric is also 0, reflecting that there is no cost associated with reaching these addresses since they are directly associated with the router itself. And via null 0, this is a virtual interface that effectively discards traffic, and in this context it means that the router does not forward multicast traffic for ff00::/8. And finally, the receive output, it indicates that the router will receive traffic sent to this multicast address range since it's a local route, and the router will process any incoming multicast traffic with a destination address in the ff00::/8 range. Okay, next we would need to jump into the next subtask where we will need to perform some connectivity and verification between branch 1 router 1 and headquarter router 1. So I am going to ping branch 1 router 1 from headquarter router 1. So I'm going to say ping IPv6, and that is going to be 2024:2000:1000 and then ::2. And you can see that we have successful ping. And now let's ping the ISP IPv6 address from the headquarter router 1. And let's check if the ping is successful as well. So I'm going to say ping IPv6 2024:2023::2. And again, the ping is successful. Next, let's jump into PC3 and PC4, or we just might need to do the test on PC3 where we need to make sure that there is connectivity between PC3 and PC4. So I'll go back to my topology quickly and I'll click on the PC3 stencil and I'll go to the command prompt, and again I will issue the ipconfig command, and you can see this is the current IPv6 address that's been assigned to PC3 interface, and the default gateway is also being assigned. So the first test I'm going to conduct is ping 2024:1000::4, and this is pinging PC4 by the way, and you can see the ping is successful. Let's ping the default gateway, and the default gateway is also successful. So at this point, if we were to initiate a ping from PC3 to PC1, the ping will not be successful, and that's basically because of a lack of routes between the headquarter router 1 as well as the branch 1 router 1. So I'm gonna jump into the next step where I need to go back to the branch 1 router 1 router, where I'm going to configure a default IPv6 route. So I will go to global config, and from there I would say IPv6 route, and then we're going to say : 0/0, and the next hop address is going to be 2024:2000:1000:1. I'm going to end this, and let's just issue the show IPv6 root command, and you can see that there is a new static entry have been configured. Basically, this means that if there is any destination that is not part of the routing table, or the router couldn't find it in the routing table, it will then use this IPv6 address as the next hop address to forward the packet to. Now, if we go ahead and try to ping PC1 to PC3, the ping again will fail, and the reason being is because the headquarter router 1 wouldn't have a clue how to return the traffic back to branch 1 router 1. Let's just try that quickly. So I'll go to PC1 and I will try to ping 2024:1000:3. As you can see, the ping is not successful, and as I explained earlier, the reason being is because headquarter router 1 doesn't have a clue how to send the traffic back to the branch 1 router 1. So let's fix this now. So I'll go back to headquarter router 1, and then I'll go to global config, and I will execute IPv6 route 2024:2000:0/64, and the next hop address for this network is going to be 2024:1000 colon 2. Actually, we missed the 2000 bit. Now that we've done that, let's verify the entry from the IPv6 routing table. So I'm going to say show IPv6 route. And you can see that we have configured a static route to this network and via this IPv6 address as the next hop address. Now let's try again and ping from PC1 to PC3, and let's see if the ping is successful this time. So I'll go to PC1, I'll up arrow, I'll hit enter. Right, there is a problem with our configuration, so let's verify that quickly. So we are saying here 2024 colon 2000 colon 0/64. Okay, let's verify that IPv6 unicast routing have been enabled on the headquarter router 1. And I would say show run pipe include IPv6 unicast. Right, okay, that explains it. So I'm gonna go to configure terminal and I would say IPv6 unicast routing. And now let's go back quickly to PC1 and try to initiate that command again or ping again. And now you can see that there is connectivity and reachability. Okay, so at this point, we can jump into step number 5, where we will need to configure a default route on the headquarter router 1, where it is pointing to the ISP IP address. So I'll go back to HQR1 and I'll go to global config. And from there, I'm going to say IPv6 route. Gonna say colon 0/0, and the next hop is going to be 2024 colon 2023 colon 2. Let's end this and do some in-flight checks. So I'm gonna say show IPv6 route, and you can see that there is a default route that have been statically configured, and you can see that the next hop is the ISP IPv6 address. So now let's move into the next step, where we will need to initiate a ping from PC1 to server 1 and server 2, as well as PC3 to server 1 and server 2. And let's see if the ping will be successful. So I will go to PC1 and I will say ping 2024 colon 2000 colon 1. And you can see that the ping is successful. Let's ping server 1. So I'm going to say ping 2024 8000 colon 1. And also we have successful ping. And then finally, let's ping 2024 colon 9000 colon 1. And we also have reachability and connectivity. So if I go back to my topology, and what we have just proved is that PC1 is able to ping server 1 and server 2. Let's check if PC3 is also able to do the same thing. So I'm going to say ping to 2024 colon 8000 colon 1. And we can reach server 1. Let's up arrow that and let's just change the 8000 to 9000. And we also can ping server 2. So that's the end of the lab, guys. We can go ahead and save the configuration. And that's it, folks, for this video. If you found this video helpful, please don't forget to give it a thumbs up. And if you haven't already, please hit that subscribe button and turn notifications so you never miss our future tutorials and tech insights. If you have any questions, comments, feel free to drop a comment below. I read all your comments and I'm here to assist you. And remember, consistency, and hands on practice are key to success. So stay curious, stay inspired, and until next time, peace.